Okay, we're first going to look at a piecewise function that we've studied in reviewing for our quiz. So once you obviously get this written on your paper, go ahead and try the problems that follow to kind of get some practice for the upcoming quiz. So our first piecewise function obviously says if f of x equals 3x minus 5 for x less than negative 5. So I'm going to label that piece 1. And that's going to be valid for any x less than negative 5. And then 2x plus 1 if x is greater than or equal to negative 5. We'll call that piece 2. So when we're looking for f of 0, that means x equals 0. So the piece that x equals 0 is going to be piece 2 because 0 is greater than negative 5. So I will plug this in to the second piece because that's where that x falls. So 2 times 0 plus 1 is 1. So f of 0 in this case is 1. B says, what is the value of f of negative 5? Well, negative 5 is in piece 2 because piece 1 is less than negative 5. Piece 2 is greater than or equal to negative 5. So it's this equality here. That means we'll plug it into that piece. So 2 times negative 5 plus 1 will be negative 10 plus 1, which is negative 9. So those are function values that you can find. Some other things we did with piecewise is we graphed them. So the way we said the easiest way to graph a piecewise function was to make a little table of values. So I'm going to make a table for piece 1 and a table for piece 2. So for piece 1, I want to pick points that are less than negative 5. So maybe negative 5, negative 6, negative 7. Remembering, negative 5 is not less than negative 5, so this is going to be an open circle. Now, for those x values, I'll simply plug into the different pieces. So if I do 3 times negative 5 minus 5, I'll get negative 20. 3 times negative 6 minus 5 is negative 18 minus 5, which is negative 22. And then negative 7, 3 times negative 7 is negative 21. Negative 21 minus 5 is going to be negative 26. So if I look at these pieces, I'll do the same thing for piece 2, which is greater than or equal to negative 5. Maybe negative 5, negative 4, how about 0? Any of these are fine. So if I plug these in, these will go in piece 2. So it's 2 times that. 2 times negative 5 is negative 10 plus 1 is negative 9. 2 times negative 4 is negative 8 plus 1 is negative 7. 2 times 0 is 0 plus 1 is 1. So if I look at piece 2, I'm going to plot these points negative 5, negative 9. Now you notice piece 1's got a lot of small values, so I'm going to go ahead and make the scale on the y-axis 2. And then on the x-axis, I'll just keep the scale to be 1. So when scale 2 means each box is worth 2, right? So if I plot piece 2, let's go negative 5, negative 9. So negative 5, 1, 2, 3, 4, 5. 9 is going to be 2, 4, 6, 8, 9. So there's my first point. 0, 1 is pretty easy. That's that point there. And then negative 4, negative 7 is going to be somewhere in between. So like there. So that is piece 2, because that is the ones greater than or equal to negative 5. Now piece 1, same idea. We're going to do negative 5, 20, negative 5, negative 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So negative 20 is way down here. And then negative 6 is negative 22, so it's going to kind of look like this. So you just graph a table for each part and then just plug it in and get your graph. So the final thing this question answers is are there any x values that have an f of x of 0? This means are there any x's with a y of 0? So are there any y's of 0? So y's of 0 would essentially be x-intercept. So if we look at that, that's going to be right there. So that appears to be at x equal negative 1. Now, again, we're just approximating because it's a graph, but we get this graph and we can kind of answer these questions.